Welcome to class, students. In this class we are going to discuss operators, equality and bitwise operators. Equality operators are logical equality, logical inequality, case equality, case inequality. When used in an expression, equality operators return logical value 1 if true, 0 if false. These operators compare the two operands bit by bit with 0 filling if the operands are of unequal length. You can observe here A double equal B, A equal to B. When you use as part of a condition, if A and B are equal, it returns logical 1 value. If A and B are not equal, it returns 0. The result is unknown if X or Z, if any of the bits of X, A and B are unknown or high impedance, then result will be unknown. So possible logical value at the output will be 0 when condition is false, 1 when condition is true, X when bits of A and B contain unknown or Z. A not equal to B, again here it is same, 0 1 X. If A and B are not equal, then 1. If A and B are equal, in that case you will get 0. If any of the bits A or B will contain X or Z, in that case final result will be unknown. Case equality, so here you can observe there are three equal to, continuous equal to signs here double equal. A equal to B means X and Z can be part of values for A and B, including X and Z as part of A and B. If they are equal, then logical 1. If they are not equal, then logical 0. A not equal to B, case inequality, here also same thing. X and Z can be part of the value. So in that case, including X and Z, if A and B are not equal, then 1. If they are equal, then it should return 0. Now if you check, if A value is 2 tick B 0 0, B value is 2 tick B 0 0. 2 tick B means 2 size of the data in binary 0 0. A is 0 0, B is also 0 0. If you check A equal to B, since A and B are equal, you will get output as logic 1. A not equal to B, if you check, okay, so this condition becomes false. Here A and B are equal, so you will get logical 0 at the output. Suppose B has value B equal to 2 tick B 1x. In this case, X unknown is part of the value, and when you compare A equal to B, say you consider first condition A equal to B, since X and Z are part of the data in A or B, so result is X. Similarly, in third equation, case equality, A triple equal B, okay, in this operator, when you compare A and B, so the value includes X, but both include X at same place, so you will get result as A equal to B, result as logical 1. So X and Z can be part of the equality operator, that can be included. If you see examples here, A equal to 4, B equal to 3, X equal to 4 tick B 1 0 1 0, Y 4 tick B 1 1 0 1, Z 4 tick B 1 X X Z. X and Z are part of the data M. 4 tick B 1 XXZ, N 4 tick B 1 XXX. Now here if you observe, X and Z are part of the values for Z, M and N. When you check A equal to B, A value is 4, B value is 3, both are integer. When you are checking equality, A and B are not equal, so result after executing this condition will be logical 0. Condition is not true, false. False is indicated by logic 0. X not equal to Y, 1 0 1 0 1 1 0 1. So values are here different. Values are different. So X not equal to Y, it returns logical 1. This condition becomes true. Not equal to Y, X not equal to Y, condition becomes true. X equal to Z, X equal to Z, if you compare X equal to Z, Z contains X and Z, unknown and high impedance as part of data. So X equal to Z will result in X. Result after executing this expression or condition will be unknown. Z equal to N. Now if you triple equal, case equality, you are checking. So X and Z can be part of the value. Now you compare each and every location bit value. So 1 XXZ, both contain Z and M contain 1 XXZ. So result will be logical 1. All bits match including X and Z. So result will be logical 1. Z equal to N. Here at last LSB location, Z equal to N. Here it is Z and here you are getting X. Rest all 3 bits value is equal. Only at LSB value is different. So you will get logical 0. Least significant bit does not match. M not equal to N. M not equal to N. In this case, it results in logical 1 because 3 locations values are same. At LSP, Z and X are different. So you will get logical 1. Bitwise operators. Bitwise operators are negation, and, or, XOR, XNOR. Okay. Bitwise operators perform bit by bit operation on 2 operands. They take each bit one bit in one operand and perform the operation with corresponding bit in the other operand. If one operand is shorter than the other, it will be bit extended with zeros to match the length of the longer operand. A Z is treated as X in a bitwise operation. Z is treated as X in bitwise operation. The exception is the unary negation operator, which takes only one operand and operates on the bits of the single operand. If you see, generally it has 4 values 0, 1, x, z. Since z is treated as unknown, so we write 0, 1, x. For AND gate, for 0, 0 you will get 0, 0, 1 you will get 0, 1, 0 you will get 0, for 1, 1 you will get 1. For remaining combination, 0, x you will get 0, x 0 you will get 0, 1 x result is unknown. Here also 1x result is unknown. Unknown, both the inputs are unknown. In that case, result is unknown. Similarly, you can analyze OR gate here. For 0, 0, operand A and B. Hello students. Here you can observe there are 2 inputs A and B. A and B. For OR gate, A and B are the inputs, Y is output. A can take value 0, 1, x, B can take value 0, 1, x. And these values written within the block, okay, as a matrix, it is output values. When 0, 0, output will be 0, 0, 1, output will be 1. When A is 1, B is 0, output is 1. A and B both are 1, output will be 1. A 1 and B value x, in that case resolve as 1. B1, A value x resolve as 1. A value as x, B value as 0, unknown, here also unknown, both input values are unknown, in that case resolve it as x. So for basic gates AND, OR, XOR, XNOR, NAND, NOR and negation, NOT gate. Okay, these tables are developed. Now here you can see negation. When 0, output will be 1. When 1, output will be 0. When input is unknown, output is unknown. So the bitwise operator takes two operands and process the result AND, OR, XOR, XNOR. Negation, NOT gate, it requires only one input. Examples of bitwise operators are shown below. X equal to 4 tick B 1010, Y equal to 4 tick B 1101, Z equal to 4 tick B 10x1. Not of x, this negation operator, not of x. So each bit individually it is considered. 1 is made as 0, next bit 0 is made as 1, complemented 1 0, here 0 is changed as 1. So bitwise negation is done and result will be if input x is 1010, output you will get it as 0101. X and y, logical AND operation, again bitwise it will perform AND operation. So MSB 1, here MSB 1, so you will get 1. Remaining bits 0 1, 1 0, 0 1. So all remaining bits output will be 0. So it will perform bitwise AND operation. So ampersand is an operator. X or Y, it is a bitwise OR operator. If you perform X or Y, one zero one zero 1101, bitwise XOR if you perform, so you will get all ones. X XOR Y, X XNOR Y, X and Z. Here Z is again it will perform bitwise and 1 0. Since one of the input is unknown, so output will be at that bit unknown, then 1 0 0. So final result that we get, we can say it is unknown. Since one of the bit is unknown, so total result we can say it is unknown. It is important to distinguish bitwise operators for NOT, ampersand, AND gate, OR gate, with negation, logical NOT, logical AND, logical OR operator. So for logic, when we discussed logical operators, we have used these symbols. When we used bitwise operator, we are using this. Okay, they are different in meaning. We'll see. Logical operators always yield a logical value 0 1 x, whereas bitwise operators yield a bit by bit value. Logical operators perform a logical operation, not a bit by bit operation. If you consider an example, x equal to 4 tick b 1010, y equal to 4 tick b all zeros. If you perform x or y or operation, then result will be bitwise it will perform OR and your final result will be 1010. If you perform logical operation x logical OR with y, in that case it is equivalent to, since it is non-zero, 1010 is a non-zero value, it is equivalent to logical 1, and y is equivalent to all bits are 0, so it is equal to 0, so it is logical 0. 1 or 0 if you perform, result is logical 1. So logical operators result in either values 1 bit 0 1 x, whereas bitwise operators will yield you bitwise, it will give you a bitwise operation since x and y are 4 bits here, result is also 4 bit. In this case 4 bit operation is performed. Thank you students, we will continue in next class.